Good morning. I am Professor Praveen BR, Assistant Professor from Sai Vidya Institute of Technology, instructing you the microcontroller programs. So right now, let us check program number one, that is without overlapping. So we are discussing the data transfer program related to microcontroller. So let us start with the programming. So the software that we are going to use for the programming is MicroVision. It is Keel MicroVision is the software which we are using for executing programs under assembly language program. So let us see the first assembly language, Keel MicroVision. So once you log into Keel MicroVision, the first screen which you are going to see is this particular screen. There are three parts in the screen. This is called the project window. This is called the output window, and this screen is called the editor window. So the step one we have to proceed is to go to the project. In project, next we are going to go to new microvision project. So step one is in the menu bar, we have to select project. Under that, we have to select new microvision project. Under new microvision project, I will give the name as without overlap. Let me give the name as without overlap. Without spacing, I am giving the name as without overlap as the file name. I will click on the save. It will ask me to choose the particular, it will ask me to choose the particular microcontroller. So I will choose the microcontroller called Atmel. So I will go to Atmel wireless and microcontroller. So click on the extension button here. You can see C microchip. So click on C microchip. Under microchip, you can see a lot of Atmel microchips. You have to select AT89C51 ED2. So when you are scrolling down, you find a particular microchip called as AT89C51 ED2. This is the microchip which is compatible to 8051 microcontroller. So we are going to take AT89C51ED2, we'll choose this and we'll press OK. It will ask to copy the startup, we'll press no. So this is the procedure which we follow for all the assembly language programs. What is the next step? The next step is go to file under menu and click new button. It will ask you to type the program. So let's type the program. So what is the program that I'm going to type? I have my program with me. So let me say I will select the program. I have already written the program. So I will go to this and I will type the program. So let me explain the program to you and then I will proceed. What is the first line in the program? So before I explain the program, let me just show you the procedure of how to follow using Keel MicroVision. So I will type the program. After typing the program, I am going to execute it. So let us see what is the next step. The next step here is click on the file, click on save as, and I will write over here as without overlap. I will write it as without overlap .asm. .asm is the extension that is given for assembly language programming. So as soon as you click on the save button, the color of the instructions changes. So you can observe the color of the instruction changes. The blue color indicates that it is the opcode and the red color indicates the first line of the program. Always use the tab button so that you will be able to understand the program clearly. So this is the steps that we follow. So let us rearrange the lines properly. I will click the tab button so that all the lines come in the order. What is the first line? Origin 00. What does origin 00 indicate? ORG00 indicates that we are originating or starting from the memory 00H. So we'll start from 00H. What is the next line? SJMP. What does SJMP indicate? SJMP indicates that it is short jump. So it jumps from the memory location 00 to the memory location 30H. So it jumps from memory location 00 to memory location 30H. Now it starts from the origin 30H here. What is move R7, hash 0AH? The data 0A is stored in the register R7. So this instruction is going to store the data 0A into R7. So what does this instruction do? The program is to transfer 10 bytes of data from memory location 8100H to memory location 8200H. So 8100H is the source address, 8200H is the destination address. So data 0A indicates that we are moving 10 datas. So that is what you say that 0AH. So 0AH is the count. So we are going to use a loop. So I will be using register R7 as the counter register. What is the next instruction? Move DPTR, hash 8100H. What does this instruction do? This instruction is going to move the 8100 data in DPH and DPL. DPH is the data pointer head and DPL is data pointer lower byte. So 81 will be stored in higher byte and 00 will be stored in lower byte. So your data pointer will be pointing towards the memory location 8100. First, the data you will be loading in 8100H. Let me say I am loading 01 as the data. What does the next instruction do? The next instruction is going to move the data from 8100H to the accumulator. So to do that, I use move x a at the rate of dptr. So what does move x a at the rate of dptr perform? It is going to move the data from the external memory location 8100 to the accumulator. So A indicates accumulator. I have to move 10 datas from the external memory location to the internal memory location. To do that, I make use of stack. The bit address of the accumulator is 0E0H. So the data that is present in the accumulator will be moved to stack. So push instruction moves the data from the accumulator to the stack. Next, what happens? I increment DPTR. So what happens when I increment DPTR? When I increment DPTR, the DPTR will show 8101 now. The data present in 8101 is 02. So once again 02 will be moved to accumulator. Once again 02 from the accumulator it will be moved to stack. So every time the stack pointer keeps incrementing, and this happens until you transfer 10 datas from the external memory location through the stack. It is moved from the accumulator. So this is what is going to happen. So every time it is going to decrement the register R7. Every time it moves the data, register R7 will keep decrementing. At one point of time, it becomes 0. Decrement jump no 0. Until it is not 0, this loop keeps on happening. Once it completes all the 10 datas, the loop will be break and it will come to this particular instruction. Which is that instruction? It is move R7, 0AH. Now the data is present inside the stack. We have to move it to the destination address. Which is the destination address? 8200H is the destination address. So it will be moved from the stack to the destination address. So what I will do, once again I'll keep the counter such that the data present in the stack will be moved to the destination address. Next, destination address is given as 8. How does the data move? The data moves with the help of pop instruction. So whenever I say pop, the data present in the stack will move to the accumulator. How do you know it moves to the accumulator? With the help of the bit address. The address of accumulator is 0E0H. So whenever I say pop 0E0H, the data present in the stack will be moved to the accumulator. The last data which you have fed to the stack will be 810A data, the 8109 data. The data present in 8109 memory location data will be some number. That number will be popped out from the stack for the first time. After it is popped out to the accumulator, the data that is present in the accumulator will be moved to the memory location 8200. So 8200 will have the last data that you have fed to the stack. So that is how it happens. Next, again DPTR is going to get incremented. So DPTR will become 8201. After it becomes 8201, next it is going to happen in such a way that it keeps taking the data from the stack to the destination address. So till 8209 memory location, it keeps loading the data from the stack. Once it completes, it's going to check whether register R7 is 00. Once it is equal to 00, it will come out of the loop and it finishes its function. So this is an infinite loop. So infinite loop indicates that it is completed the program. So let us see how do you execute this program. So to understand the execution, the next step which you are going to follow is go to the target file. So right click on the target file. Right click on the target file. You can see options for target. So click on options for target. Here the crystal frequency you have to mention is 11.0592 megahertz. This is the crystal frequency at which you are going to operate 8051 microcontroller program. Next, you will go to the output tab. In the output tab, you will click create hex file. Next, you will press OK. Next, you are going to expand target 1. You will find source group 1. In the source group 1, you are going to right click on it and you will click on add existing files to group. You will choose add existing files to the group. When you click on it, it will ask which program you are going to choose without overlap.asm and you will click on add button. So this indicates that you have added the program to the Keel Microvision software. Next, you have to click on translate window. Where do you find the translate window? It is found in the menu bar. So the first uh, column of the third row is translate button. So click on the translate button and check whether there are any errors. So it is going to compile and see whether there are any errors. When there are no errors, once again you will build. After translate, you will convert it to the hexadecimal file. Then you will rebuild it. So this is how you perform and check whether there are any errors. Once there are no errors, you will go to the execution window. How do you go to the execution window? In the menu bar, you have File, Edit, View, Project, Flash, and Debug. So click on the Debug button. There you find Start Stop Debug Session. So click on Start Stop Debug Session. It will give you this window running with code size limit 2K. So press OK. You will go to the debug screen. Here you are going to perform the program. So what do you do? Go to the view in the menu button. Check whether you have selected the two memory windows. You require two memory windows. One is the input window and the other one is the output window. So first I will select the memory window 1. So let me go to the view button. Let me go to the memory window. So you can see I have chosen memory window 1. Next, I will go to view once again. I will go to memory window and I will choose memory 2. So we have chosen memory window 1 button, memory window 2 button. In memory window 1, I am going to write in the address bar X. X indicates external memory. I write colon. I write 8100 and hexadecimal is represented by H and I will put enter. This indicates that I am only entering hexadecimal numbers. Next, I will enter the data manually. In 8100, I will enter the data manually. What are the data? I will give any 10 datas. Let me say I am entering 01, 02, 03, 04, 05, 06, 07, 08, 09 and 08. How many datas are there? There are 10 datas. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Output is seen in the memory window 2. So in the memory window 2, in the address, I am going to write it as X colon 8200 H. H indicates it is a hexa number. I will put enter. Now I am going to show you how to execute the program stepwise. In this first step, how do you go stepwise? By pressing F11 button. First, I will press F11 button. So what happens? It goes to the fourth line. The program counter will go to the fourth line. So the next instruction that it has to execute is register R7 should be loaded with 0H. So you can see initially R7 will be 00. So when I say R7, the next instruction, it loads with instruction, that is move dptr comma hash 8100. Your data pointer is pointing to 00 location. When I say move dptr comma hash 8100h, it is going to point towards 8100 memory location. The data present in 8100 memory location is 01. The accumulator is showing 00. Whenever I say move x a comma at the rate of dptr, the data present in 8100, that is 01, will be moved to accumulator. So you can observe over here, your accumulator will become 01. This data will be moved to stack. How do you know? The stack initially will be having stack pointer with the address 07. Every time when I load the data into the stack, your stack pointer gets incremented. So initially the stack pointer will be 07. When I increment, 07 will become 08. So all of you can observe it became 08. So what does that indicate? The data from the accumulator has moved to stack. Next, increment dptr. So what does this instruction do? The data present in 8100, it is pointing, the data pointer is pointing towards 8100. So dph has 81, dpl has 00. Now dpl will have 01. So let us see, it will have 01. Next, what is it going to happen? Next, it is going to check whether the register R7 is still having 0A or not. How does it check? It has completed one operation. What is that one operation that it has completed? The data 01 has moved to the stack. So it will decrement the data present in register R7. So R7 will become now a minus 1 is 9. So you can observe it has decremented the count because one data is transferred from the external memory to the stack. Next, what is it going to do? It is going to check whether 9 is equal to 0 or not. Is 9 equal to 0? No. So it will go back to loop 1. So in loop 1, what does it do? The data pointer is pointing towards the memory location 8101. The data present in 8101 is 02, which will be moved to accumulator. So you can see in the place of A, you will have 02. So let us see, accumulator will have 02. 02 is there in the accumulator. That 02 will be moved to stack. How do you know it has moved to the stack? The stack pointer will get incremented from 8 to 9. Has it got incremented? Yes. Next, what it will do? It will increment the data pointer data. From 8101, it increments to 8102. So like this, 10 datas are going to get incremented. How do you know? Every time when it is incrementing, the register R7 keeps on decrementing. The data present in R7 keeps on decrementing. So it is moving from external memory location to the stack. So you can observe at one point of time, R7 will become 01. The data that you are moving from the data pointer 8109, that is 0A, will come to accumulator now. This is the last data. From that, it will go to the stack. Your stack will get incremented to the next number 11. Next, it will increment. It will become, the data pointer will become 810A. Next, it will compare, it will first decrement the data present in R7. R7 will become 00. 00 is compared with the register, the data present in present in R7, the data present in R7 is also 0, 0. So since the data present in R7 and 0 are same, what do? It will not go to loop 1. It will come out of the loop. Now your R7 will get moved. R7 will become 0A. From the stack, it has to move to the destination address. So your destination address thereafter will not be 810A, it will be 8200. So all of you can observe here the data pointer will be pointing towards 8200. So the data that is present in the stack, which is the last data that is present in the stack, 0A, will be moving to the accumulator. So let us see whether it has moved to the accumulator. Yes. Every time when the data moves from the stack to the accumulator, what happens? It is going to decrement the stack pointer. The stack pointer was 11, it became 10. After that, the data present in the accumulator will be moved to the memory location, external memory location pointed by data pointer. So data pointer is pointing towards 8200. So the data will be moved from the accumulator to 8200. So all of you can see 8200 has 0A. Next, it will increment from 8200 to 8201. So you can observe your DPTR will be 82. So before going to the next data, register R7 is going to get decremented. What is the data present in register R7? A is the data. So A minus 1 is 9. So it will become 9. So after it got decremented, 9 is checked with 0. Is 9 equal to 0? No, 9 is not equal to 0. Since 9 is not equal to 0, what does it perform? It is going to go back to loop 2. Next, what it does? It is going to pop the data from the stack to the accumulator. So what is the next data that it has to pop? It is 09. So 09 is present in stack. All of you know 09 is present in the stack, which will be popped to accumulator. So all of us, let us see. 09 has popped to the accumulator from the stack. Next, from accumulator, it will come to 8200. So you can observe it has come. Next, it will increment from 8201, it will increment to 8202. Like that, it keeps happening and it keeps transferring. So all of you can observe here that all the 10 data are transferred from memory location 8100 to memory location 8200. So aim of the program is to transfer 10 bytes of data from 8100 memory location to the memory location 8200, which we have performed. So all of you can see it has moved 01, 02, 03, 04, 05, 06, 07, 08, 09 has been moved from 8100 to 8200. So this is the first program which is explaining without overlap. Thank you for watching the video. Thank you everyone.